So I'm Vishwa, I'm part of Oasis Engineering. So welcome to everyone. Thank you so much for being here for the Oasis edition of the IDEO Coin List Hackathon workshop. Okay. So what I'm going to be talking about today is building privacy preserving applications on the Oasis blockchain. So here is the outline. Yeah. So what we'll cover is why Oasis, why do you have to build on our platform? In this, we will cover challenges with the existing internet status quo, and then overview of our network, followed by how to build on Oasis. And in that part, we are actually going to go through a simple example where we will show you how you can go about building a Rust program, testing it, and then deploying it on what we call local chain, which provides blockchain semantics, which are similar to what you'll see on the DevNet. So data breaches are a thing that's been so ubiquitous over the last 10 years or more. We've seen that there are millions of records, personally identifiable information that gets stolen. And this is not necessarily because of commission, but more often than not, it's because of omission. You find that people haven't taken care of the best security practices, though there are state-of-the-art security tools that are involved from firewalls through IDS, IPS, you name it. Despite that, we see that there are a lot of leaks that have happened, and they happen somewhat periodically and consistently. And so this is certainly a cause for concern, so which means that there has to be a solution that addresses this in some way. And then this was a survey that went out at the end of 2018 where people were asked if they trust Facebook, and the response is very clear. More than 50% of the respondents felt that they don't trust Facebook. And this is unlike in the previous case where there may have been human error in the way in which things were configured. In this particular case, it's clearly because of commission. It's not omission, it's commission, because Facebook did share data with third parties that without the expectation or without the awareness of the people that were contributing that data. So, and this is again a huge problem that we have, and it's only going to grow. So to address this, we need a solution for sure. And one other thing that we've been noticing through some of our partnerships is that when enterprises or companies want to provide services, like if data becomes a product, then they need to be able to build, for instance, machine learning models using private data that comes from multiple sources. And then this then becomes something that they can sell in a marketplace. And also when companies want to take care of infrastructure, these could be critical infrastructure in spaces such as oil and gas, for example, or it could be IoT devices, or it could even be in infrastructure hardware that you deploy in data centers. And you have to take action based on data that is actionable data, which could be telemetry coming from these devices, or it could be other actionable intelligence. Again, there you want to ensure that whatever action is being taken has a high integrity. And in many cases, we also need confidentiality. I mean, especially if you are looking at a data market where data becomes a product, then clearly we would need to make sure that the producers of data can be assured that the data is going to be handled in a confidential way. And of course, malicious actors, including nation states, might thwart your attempts at controlling devices. And this is one thing that exists as a threat, even if you have an on-prem setup. So whether you're on-prem or you are on one of the public clouds, we see that malicious actors can inject malware and then do things that are not expected. So which means clearly high integrity is one of those things that is required in this space as well. So what we want to do at Oasis is to empower you to build secure and decentralized applications that keep data private. And that is our overarching mission. We want to make sure that the problems that we've been citing so far are things that can be addressed. We believe they can be addressed. And we want to make sure that we empower people, developers, not just blockchain-aware developers, but also developers that come from different sectors to be able to take advantage of our platform to be and build solutions that keep data private. Yeah, so the problems that we see are untrusted infrastructure. So this could be, the cloud providers have overprivileged, identities that can gain access to services that you're running in the cloud. Or it could even be misconfigurations that exist in the nodes that are running services for applications. You could have untrusted applications, which is the application that you expect to be running as a service in the cloud may not necessarily be the one that is actually running. There could be malicious code that gets injected. There could be changes that happen in the result of computation before they actually get committed. So that also could be one way by which you can lose integrity. And then there could be vulnerabilities, of course, in applications which can be exploited by malicious actors. And then all of this, of course, leads to undesirable data leakages. And this can again happen because of omission or commission, as we were saying earlier. And these are problems that we perceive, and these are problems that need a solution. And our solution is one where we start with providing a scalable smart contract execution platform. And then we are a microservices-based application. So what we do is to have independent scaling abilities for our microservices, which is the way in which we can achieve scalability. And then we provide confidentiality preserving smart contract execution. What that really means is we have these secure enclaves within which your code is going to execute, and that gives you a lot of guarantees, as we will see in subsequent slides. And then there is privacy preserving analytics and machine learning. So what we have seen so far in our solution, the first 2 points cover layer 1 functionality, whereas what you see at the bottom is more of a layer 2 functionality, where you want to provide libraries that can be made use of to build, for instance, data for sharing, models, for example, machine learning models for sharing, such that no information that went into training those models actually gets released as a part of or can be gleaned by using those models. Yeah, my slides take a little longer to shift, to move. Oh, what happened? Yeah. Okay, so ensuring high integrity. So this is something that not just Oasis, but other blockchain platforms also provide. What this really means is we need an integrity in 2 places. One is we need integrity in storage, and then we need integrity in compute. What we mean by integrity in storage is that once something is committed, you don't want it to ever be tampered with. You cannot have, you need to have immutability of the records that actually get committed. So this is something that a blockchain provides by design. And so we have integrity in storage by virtue of using a blockchain. And then now you need to make sure that what is being committed to the blockchain is also comes with high integrity. And this is achieved by using replicated compute, typically with consensus-based mechanisms, so that your code and your data that the code acts upon are executed identically. Exactly the same piece of code is executed on multiple machines, multiple nodes, and then the result of the computation is then compared in a consensus step, which is after which either the result is accepted for committing to the blockchain or it's rejected. So that is the way in which existing blockchain platforms, including Oasis, provide integrity. But if you think about smart contracts, then smart contracts simulate a trusted third party for transactions between different identities. And the results are guaranteed to be correct because the code is persisted on the blockchain, which gives you high integrity. And so when you want to execute a particular method in a smart contract, this is an RPC call that you make, and this is guaranteed to be exactly what you expect because the code is pulled out from chain, and then it's going to be executing inside of your compute nodes. And it does not require trust among any of the parties, and also smart contracts can read/write data to a distributed ledger. And the distributed ledger provides immutability, and we have high availability and integrity as well. And this is the place where we can commit logs, transactions, transaction histories. So which means that from an audit standpoint, having things on the blockchain makes it much easier because you can be assured that the data that was persisted, all of the transactions that ran have very high integrity. So, but this alone is not sufficient for providing privacy. And why is that? If you think about it, you have a piece of code that wants to use some data, which could be private or sensitive data. That data is either consumed in its raw form, which means it is consumed in its unencrypted form, or even if it is encrypted, it can get decrypted in memory, and then the program is going to act upon it. In either of these 2 cases, it exposes data, sensitive information to malicious actors, including nation states. And so the ideal functionality that we would want is one where the program executes inside of an environment, the black box that you see over here, where data is encrypted. The encrypted data goes into the black box, and it can get decrypted only using keys that are available within this black box. The program has access to the data. The program decrypts the data, consumes it, produces a result, which can then be persisted in an immutable ledger, distributed ledger, either with encryption or not. So what we use for confidentiality are secure enclaves. Intel SGX is what we use in our platform. So our compute nodes have Intel SGX. And Keystone is another interesting project, which is an open source secure enclave. This is a project that we are participating in along with multiple universities and many industry partners. So once Keystone becomes available, we expect that we will be able to support both Keystone as well as SGX. Moving on to building on the Oasis platform. If you think about smart contracts, you can think of them as state transformers. And what we mean by saying state transformers is that there is a particular state that is persisted on the blockchain. So every program has state associated with it, which is persisted. And so each time you execute a transaction, a method in your program is going to get called, the method may change the state of that program, which means that it may propose a new state to be committed to the blockchain, right? So in that sense, contracts are state transformers. Given a state, they propose a new state to the blockchain. So the commit to the blockchain happens post consensus, so that we want to make sure that there is one universal truth in terms of what the state of a particular program is. So this, of course, gives us integrity. We have immutability in the record of actions, and also confidentiality by virtue of using secure enclaves. So what we're doing is working on a set of tools and libraries to make application development easy. In fact, as I was mentioning earlier, we want to reach out to as many people as possible, because the problems are pressing enough that we feel that we need to engage with a very, very large community. And for this, the way in which we envisage providing this functionality is by making it easier for people who may not necessarily be blockchain savvy or blockchain aware to also be able to build on our platform. So towards this end, we have a new release that is coming out in a couple of days, in fact, where we have an Oasis development SDK. This is a new Rust development library that abstracts away many of the things that you may be aware of if you have been programming on top of blockchain platforms so far, including ours. And it also makes the development process much easier. In fact, you'll see examples of this when we walk through our demo. And then there is the WASM runtime, which provides, there is binary portability. So what this really means is that you can build anywhere, and then you can run it on our platform or on any node that supports our platform. And then we also have a dashboard. The dashboard is something that you can use to monitor your deployments, your services. You can monitor their activities, how they're being used. In fact, if you are a provider of a service or an application that others are making use of, you can see what the level of engagement is with your service, and so on and so forth. So we provide analytics that you can make use of to see how well your services are doing. And of course, managing your tokens. So for the example, what we're going to do is to go through a simple hello world example. So for that, what the program does is simply print hello world. Given a 2-letter country code, it'll print hello world in the language of that country using the Latin alphabet. So let's move on to the demo. So for this, what I've done is, let's use the quick start guide. So we have, this is another thing that I wanted to mention. We have a bunch of documentation that will help you get started. The best place to start is the quick start guide, where we walk you through how to set up your environment to be able to build and test pure Rust programs before you actually turn them into a service that can run on top of our platform. And then we have other documentation that we will also make available. In fact, that I think will happen soon enough after the meeting, I would expect. Yeah. Then if you look at the quick start guide, there are a bunch of setup steps at the beginning. I have gone ahead, because these things take a little bit of time. What I've done is to set up a Docker instance, which has many of these things already done for us, the first 5 steps at least that you see under installing the Oasis toolchain. So we have installed Rust. We have also installed our SDK. We've installed our client. We've installed what we call the local chain. So let me just show you where these things reside. If you go to cargo bin, you will see that we have Oasis, which is our CLI. Then we have Oasis build. Oasis build is a binary that actually uses, that is used to transform your Rust program into a service that can run on Oasis. And then we have Oasis chain. We will go through each one of these things in turn. So the first thing that we're going to do now is clone the tutorials directory. Repository. And then we are going to go into hello tutorials, hello world service. So let me just walk you through the service first. We have a standard cargo toml, where we have a couple of interesting things. One is, you'll notice that there is Oasis standard. There is also Oasis test. These are crates that we provide, which provide blockchain semantics and functionality that abstracts away many of the nuances of the blockchain, as we were mentioning earlier. So if we go to main.rs, you'll see that the hope here is that the code that you see over here is going to be as close as what you would write, where you're not targeting a blockchain platform, right? So that is the goal. So you see that when we instantiate hello world, we have a map. We use a hash map that has it's pre-populated with a few countries, English, Slovenian, German, and French. And then there are a couple of methods. One is say hello, which takes as input 2-letter country code and then looks up the map and prints the result. And then we have add hello to enhance this functionality. We can add more entries to the map. So this takes a 2-letter country code and hello world in the language of that country. And then there are a couple of errors that we also process. One is duplicate entry. You can't replace what already exists in the map. And if it doesn't exist, then we go ahead and insert it. And this is where the auto magic happens. The fact that we have Oasis standard service, this is what informs Oasis build that hello world has to be transformed into a service. And then if you look at tests, we have a few happy paths and a few unhappy paths. For a happy path, we ask for hello world in Slovenian, and then we ask for one in Samoan, and that doesn't exist, which should error out. We then take it through this path of trying to insert something that for a country that already exists. And finally, we fix the problem for Samoan and get the result and print it out. So we can go ahead and do Oasis build. So this is something that is interesting. We ask this initially, whether you are okay with enabling telemetry. And so if you say yes, then we will collect some telemetry and you have access to it. And this is something that we will use to improve your experience. So once we say go ahead, it's going to go ahead and build and also convert this into a service that we can later deploy. So this will take maybe 15 seconds more. Yeah, so in the meantime, maybe I should tell you something about Oasis chain. So when you run this as a pure Rust program, so the flow that we envisage is one where you write in Rust, you test in Rust. This is using pure cargo flow. Oasis build, Oasis test is a proxy to cargo build and cargo test. And so this is what we expect will be an initial engagement. And once you have your program working, then you can go ahead and deploy it on the local chain. Now, when you're running it as a pure Rust program, we have an in-memory chain. So the in-memory chain is the one that supports the same semantics, blockchain semantics. So you can test against that. And once that has been done, you can go ahead and use the local chain, which also provides blockchain semantics. It also has a gateway, which will accept transactions. And then we will see all of that in just a couple of minutes. Okay. Done. So if we say Oasis test, which again comes from the quick start, by the way. So we say Oasis test, no capture. This gets passed down to cargo test. Yeah. So let me bring up Oasis chain. When you do that, you notice that there are a bunch of addresses, accounts, private keys, and there's a mnemonic. This supports this finished Oasis test. And as you can see, we were successfully able to retrieve hello world in Slovenian. In Samoan, we got none. And then we tried to insert something for English, and that resulted in a duplicate entry. And then we fixed the problem for Samoan, and then we managed to successfully get back hello world in Samoan. So to run this on the local chain, you go back. So the organization of this directory, this is something that I should have covered. So service is the one where you have your Rust program. And then app is where you're actually going to be testing it. So app, there is a TypeScript test that we have over here, which does something similar to what the Rust test did before. But here you're going to be creating an instance of the service. We create a workspace automatically, and hello world is over there. So you create an instance of service. You deploy it with confidentiality being false, because for this, we don't really expect confidentiality. We don't need. And then for hello world, yeah. And then we have, once it's deployed, we can check that it was successfully deployed. And then we, of course, retrieve hello world in Slovenian. And then we do this as an atomic operation over here in sequence so that we can test all of these things, because these tests can run in any order. So now that that is taken care of, we have to do an npm install post which we will be deploying and testing on the local chain by using Oasis tests again. Yeah, and the way in which we've written this now is when you run Oasis tests, it's very context aware in the sense that it's going to pick the closest artifact, which could be a manifest if you are in any of the cargo areas and the Rust areas, or it will pick up package.json if it happens to be in the app directories or the app subdirectories also. Thankfully, I didn't go through the installing of the Oasis toolchain because that would have taken us a good amount of time, as in 5 minutes or 10 minutes. Okay, so now we are good to go. We will say Oasis profile equals local to pick the local chain, and we will say Oasis test. That should do it. Ignore these, we'll fix them. Yes. So this is the way in which you can go about testing it locally. And then once you test it successfully on the local chain, you can deploy it on DevNet. And then you should have absolutely no problems. If it works on the local chain, then it should work on DevNet. So we expect that we will have DevNet available for you to use by the beginning of next week. And then we can take it from there. And then we'll make a bunch of documentation available. Yeah, I think that is pretty much it at this point. Gavin?
Yeah. Okay. Well, really nice work. I mean, that's a lot in a short period of time, especially for people who are brand new. So here, I'll kick this off. So I'd say let's open this up to, if you're okay with it, let's open it up to the attendees for Q&A in terms of just, for everybody who's listening, it's like the team is on the line. So if you have questions about anything about the protocol or prototyping with it or anything like that, please throw them out right now, and let's use this time effectively. Okay, I guess here I'll start with one. I guess while people are kind of queuing them up, are there any areas, since teams are deciding kind of what to build, are there any areas that you'd like to see people push or prototypes you'd like to see built with Oasis? It's basically like areas you guys would like to explore but haven't had the time or bandwidth as a team.
I see, for sure. So anything that requires confidentiality clearly is one that's going to be interesting for us, because that is the way in which we distinguish ourselves from the other blockchain platforms. There are a few others that might also have confidentiality, but the thing is that for us is one of the most critical pieces. And so, and then if you move up one step above confidentiality, if people want to build privacy preserving applications, which means if they want to build any kind of analytics applications, that would be also very interesting. Besides that, completely open, because we can see that, yeah.
Yeah, I'd say, let me get on here as well. 1 second, everyone.
Yes. Anne is going to also join us.
Hey, everyone. Yeah, I think everything Vishwa said is exciting and really great to build on. I'd give some really, simple examples of things we've seen are around sharing data that may be private or sensitive in some way. So those are great examples. Secret messaging apps, social networks where you want to keep particular information private. Those are things we've seen. I'd say on the enterprise side, we've also seen things like financial auction apps or mediation apps where you might have two parties that need to negotiate but don't want to share that information. It needs to be held in escrow, essentially, privately. So that's sort of an interesting use case in supply chain. So there's a lot of fun things. I think the key for us is, as Vishwa said, on one hand, we're a smart contract platform, so build whatever you'd like. That's exciting. On the other hand, and in addition to that, one really unique value that we add is confidentiality. I also wanted to answer, I see two other questions in here, one from John on SGX. Yeah, I'd say, you know, we use secure enclaves. SGX is one of those. I'd say in the long run, so I'll talk sort of long-term and then some short-term stuff here. In the long term, we're very involved in a project called Keystone, which is an open source secure enclave project, really to avoid this kind of goal. Obviously, the idea is that it can be more secure because it's open source. The code will be verified. It's not controlled by one company, so there's more, you know, broader support of it. That's obviously in an earlier stage, but we're seeing some development on that front, and I can add a link to that. So that's a long-term view of how we think we'll get there. Don's mentioned some quotes in previous speeches, our CEO, to say, you know, in 10 years we expect every chip in the world to have a secure enclave. So we think it'll certainly go much beyond SGX in the long term. In the short run, I'd say, in addition to SGX and secure enclaves, we use other secure compute technologies as well. So that's true for the system overall. So that's one component of our confidentiality. But there are others that we're working on as well and that we're investigating, including zero knowledge proofs. We should have a blog about that in a couple weeks. So totally understand. Obviously, you never want to be too dependent on one technology or certainly one technology vendor. So that's something we are actively looking to make, you know, not a dependency for that reason. I also see a question on here about is your DevNet launching in a few days? Which one should we use? So yes, the documentation link that I just put in here, and that's linked on the CoinList site, goes to our entirely new documentation portal. And that has all the information you need to build. Apologies, I know this is slightly confusing today, but the timing actually worked out really well for us because we should have everything ready to go when you guys get started on Monday. And so, you know, use the new DevNet. It's called DevNet 2.0. We have a new Oasis SDK that you'll be able to use as well. So we promise that will be ready by the time, and you know, you guys will be able to build with that. You know, also, of course, if you have questions along the way, just ping us. We've got we'll have an intercom channel set up, but also we have Gitter that's linked on our website. You can always email us. You can email me, anfaber@oasislabs.com, and we'll make sure we triage any issues as quickly as possible.
Yes, absolutely.
Yeah.
And on SGX, one more thing that I should say is that we've found that when there are vulnerabilities discovered in SGX, Intel fixes them, but of course, no one really knows how it's been fixed and whether that exposes more new vulnerabilities. And so this is something that is not tenable. So going forward, we expect that with Keystone, we might be able to address many of these things, because I think the right way to do this is open source. For the enclave, for all of the software that we build, everything is going to be open source, because that way we can use crowd intelligence to figure out if there are vulnerabilities that need to be fixed. I mean, it's always, there will be vulnerabilities, but then as long as we have more people looking at them, it makes it possible for us to be very, very reactive, very quick at fixing them.
Yeah. Let's see. I read up on Keystone. Lots of questions coming in.
Ooh.
We have some additional news about privacy issues. Is that a question about Keystone specifically, John? Seeing this note. Let's see. Yeah, John, we might need a little bit more info on that question.
What's that? What's the question?
Oh, if you open up your chat.
Yeah, I've not done that. Let's get at that. Just a moment.
Mm-hmm.
What is it?
Should be at the bottom of your screen.
Mm-hmm. This little chat icon. So let's go. Sorry, everyone. Basic technical difficulties as it happens. You can get.
I wonder if because you're sharing your screen.
Yeah, out of the Mac screen, I think it might help.
Yeah. Or share. Okay, so let me just do that. And that will probably take care of things. Maybe I can just stop sharing. that's probably better. So now,
So maybe let's start with the question from
Chat.
let's see, Gilles. I think is probably the most recent one.
okay.
And it looks like John's followed up with, he thought you mentioned there would be more announcements in a few weeks.
Oh, I'm sorry. To clarify that, I was just going to say we'll have a blog on some of the things we're looking into on the zero knowledge proof side. You know, we're still a system in beta, so I think obviously there's a lot of implementations we're working on, but really right now built for development purposes. You know, so John, I see your point on absolute privacy. I would just caveat that, of course, we're still working through some bugs and issues to make it as absolute private as possible, but that's what we're building towards.
Yeah. Yeah, and docs will be available on confidentiality pretty much on all of the things. The tooling that we have, there is a question from Giles.
Mm-hmm.
So we'll have documentation pretty much for everything, including the way in which we have realized confidentiality protocol. We have a couple of papers that are coming out, which are going to be somewhat technical in nature, but then that will probably be a great place to start to understand more of what the underpinnings are for the technology that we have built so far.
Yeah, and I'll add a link in here as well, which I'll send to you. We do have a non-technical primer, so if you're just interested in learning about some of the overall, let's see, the overall architecture of our system and how we're designing it, that may be a helpful place to start as well. And you can see how we've thought about integrating a lot of these secure compute technologies. You can find that on our website, oasislabs.com/primer for others who are interested.
Yeah, and on examples, by the end of the week, we expect to have secret ballot. I suspect it's already working, but then, yeah, we will be having updates to our tutorials, because you see that the tutorial repository at this point has just the secret ballot and it has hello world, but then we are going to be adding a few more examples there. In fact, we also want to have an advanced tutorial, which will happen sometime soon, which will include cross-contract calls. And then, yeah, so the tutorials is the place where you can look for, I don't know, services that are of increasing complexity, and that would be a good place to start to be able to see how you can go about building your services. Yeah.
All right. Well, let's give them another minute here in case there's any last questions that folks have.
Yeah, I'll say just really quickly, I can show, maybe we can just really quickly walk through where to find things on our platform. So
that'd be great. We've got time, so you can, I mean, feel free to give people whatever you think is needed.
Yeah, totally. So hold on one second. I'll pull up a screen here. So am I sharing my screen now?
Yep.
Okay, great. So just so folks know, you know, obviously things are in a few different categories. So if you're looking for high-level information just about how the system works and, you know, how we've thought about it, our website's a good place for that. If you go to technology, you can see a primer. As I mentioned, this is a non-technical primer. So basically what that means is there's no proofs, but it's an overview of the system. In addition to that, of course, you can always find stuff on GitHub. So we'll go here and we'll have all of our open repos there. Let's see. And then what we'll be launching, and so you guys can see this was the documentation you all should use, but all the documentation that you'll need to build on our network will be located here, help.oasislabs.com.
Hey, I'm not sure the only screen I'm seeing on mine is a Google Docs screen. So if you're hopping around between tabs.
Sorry, oh, I shared the wrong screen. Okay, let me start over again. Sorry about that.
Oh, good.
Cool. Well, you guys just saw all the things that I so super private. Apologies for that. Okay, sorry, starting over again. So if you want an overview of the system, you can go to our website. There's a primer here as well, which should be helpful. We also link to GitHub, which will have all of the open repos we have, and really we're open sourcing stuff every day. So it's a good place to check and look, github.com/oasislabs. And then finally, the last thing I'd say is our documentation is at help.oasislabs.com. And there you'll find the Hello World example that Vishwa gave, as well as some other examples you can try out, as well as some of the information about other tooling that's actually all coming out this week. So lots of cool stuff there. Let's see. If you're curious about what I mean when I say what's new, we have a whole article on some of the big things that are coming out. So you guys can take a look at that here. It might help summarize some of the stuff Vishwa went over in a little bit more detail. So that should all be here. We also link to a couple Rust libraries, which may be helpful for folks as well. So it's a good place to get started. Last but not least, if you're interested in or you need help as you're building, there's a couple ways to do this. One is just message us on Intercom. This, again, should launch very quickly in the next day or two. So message us there. If for some reason we're not there, if the hours are off or something like that, you can also go to, let's do this here. Let's see. To our Gitter. So if you click on Community and Community Forum, we actually end up answering mostly technical questions in here. And frankly, folks are really fast. So feel free to always put any question you want and we'll get back to you really quickly. So that's another great channel to just talk to us quickly about whatever you need. So yeah, that's just a quick rundown. It should all be pretty straightforward, but as I said, just you know, ping us if you need anything else. I see two more questions in here. Let's see. I'm from the Bay Area. Is Oasis Labs opening space for meetups so we can ask questions in person? That's a great idea. So Swain, I'd say, you know, let's start by, you know, emailing us and yeah, happy to schedule something if it's of interest to folks on here in the next week or so. Yeah, very happy to do that. Cool. Yeah, thanks for coming to the Waza meetup.
Well, also feel free to come over here and then spend some time with us. And then we can chat, and then we can unblock you.
Yeah.
Yeah, that's also something that can be done.
Yeah, just
in the city, so.
I'm now that you've seen all my work documents, I'll now give you my email address. Feel free to email me if you guys want one-on-one time with any of our engineers.
Yeah.
Send me a note, and I can set something up. That may be the easiest, frankly, instead of a meetup. So very happy to do that. Got a lot of folks here who are really passionate about what we're working on. Yeah. And we'll be happy to spend time with you all. Yeah, I see one more question on truffle in here.
Truffle.
So I'll let you answer that one.
Yeah, so that is something that is going to be deactivated. We have a new CLI, which is what we expect to use going forward. Right. So we're not going to be supporting truffle.
Yeah. Cool.
Yeah.
Great. All right, everyone. Well, thank you very much for the time today, for pulling everybody in, for gathering the community and sharing with all the effort that's been going into this over the last for the last while, actually.
Yeah, cool.
No,
Thanks
thank
so much,
you.
Gavin. Yeah, and you know, again, just to remind folks of the prizes. You know, Gavin, correct me if I'm wrong on any of this, but the first place prize is $10,000. The second place prize is $5,000, and the third place prize is $2,000. And all of those come with different various tiers of mentorship from both us and IDEO. So it's a great opportunity. If you're waiting to kickstart something you're working on, why not get paid while doing it? So yeah, awesome way to get involved, and awesome way to get some mentorship from.
Yeah, and mentorship. And mentorship in a number of areas, right? You got engineering support from the brilliant people like you guys who are sharing. You've got engineering support over here as well as design support. So you've got kind of this full network that's here for this one. So I invite you to make use of it.
Got it. And John, I think just wanted to clarify. So in Truffle, we're literally supporting it today, but turning it off tomorrow. Yeah. So we have our own CLI that you'll have access to tomorrow. So no head starts. We're making sure this all launches.
Right, just in time for the 5th of August. Yes.
Yeah.
And as a heads up for everyone who is listening, this is being recorded, so we'll have links out to everybody, so we'll make sure everybody has everything by the end of the week.
Cool. Sounds good.
Love it.
Thanks so much, guys. Really appreciate it.
Okay.
Thank you.
Bye, you guys. Thanks for the day, and adios to everybody who was listening. Thank you.